Minerals and energy resources. Chalo सीधा शुरू करते हैं. First, the big idea. What are minerals? They are homogeneous, naturally occurring substances with a definable internal structure. Think of them as Earth's natural treasures. But here's the catch. They are non-renewable. They take millions of years to form, so we can't just make more. This also means they are unevenly distributed. Some states are rich in certain minerals, while others have very few. That's why it's our national duty to use them wisely and sustainably. Now, let's classify them. Broadly, minerals are of two types, metallic or non-metallic. It's a simple but crucial distinction. Metallic minerals can be further divided. If they contain iron, they are ferrous. If they don't, they are non-ferrous. Ferrous minerals, the backbone of our industry, include iron ore or manganese. And in the non-ferrous category, we have valuable minerals like copper, bauxite, and lead. On the other side, we have non-metallic minerals. These don't contain metals but are incredibly useful. Key examples are mica, known for its insulating properties, limestone, essential for cement, and gypsum. So, where do we find these minerals? Remember the mnemonic VBP for their occurrence. V is for veins and lodes. In igneous and metamorphic rocks, minerals often seep into cracks, forming thin veins or larger lodes. B stands for beds and strata. In sedimentary rocks, minerals are found in layers, formed due to deposition and concentration over ages. And P is for placer deposits. These are valuable minerals like gold and tin found in the sands of riverbeds and valleys, washed down from the hills. To extract these, we use different methods. Open cast mining is for minerals near the surface. Shaft mining involves digging deep vertical shafts to reach mineral deposits far below. And for liquid gold, like petroleum, we use drilling. But remember, mining has hazards. It can be risky for miners and harmful to the environment. That's why advanced technology and strict safety regulations are so important. Let's talk about specific minerals, starting with the king, iron ore. There are two main types you must know. Magnetite is the finest ore, with high iron content and excellent magnetic properties. Hematite is the most used industrial iron ore, though its iron content is slightly lower. India is rich in iron ore, found in 4 major belts. Remember these: the Odisha-Jharkhand belt, the Durg-Basta-Chandrapur belt with the famous Bailadila range, the Bellary-Chitradurga-Chikmagalur belt in Karnataka, and the Maharashtra-Goa belt. And its primary use? Making steel, the foundation of modern infrastructure. Next up, manganese. It's a silent hero. Nearly 10 kg of manganese is needed to manufacture 1 ton of steel. It's also used to make bleaching powder, insecticides, and batteries. The major producing states are Odisha, which is the largest producer, followed by Karnataka, Maharashtra, and Madhya Pradesh. Now, for a non-ferrous star, copper. Being malleable, ductile, and an excellent conductor of heat and electricity, it's indispensable for electrical wiring, electronics, and the chemical industry. India's copper reserves are low. The key locations to remember are the Khetri mines in Rajasthan, the Balagat mines in Madhya Pradesh, and the Singhbhum district of Jharkhand. Then we have bauxite. This is the ore from which we get aluminium. Aluminium is prized for its strength, extreme lightness, good conductivity, and resistance to corrosion. It's used in everything from airplanes to utensils. India's largest bauxite deposits are found in Odisha, especially at the Panchpatmali deposits in Koraput district. Other major producers include Gujarat, Maharashtra, and Jharkhand. Moving to non-metallics, let's talk about mica. It's a fantastic electrical insulator, which makes it vital for the electric and electronic industries. India is a leading producer. The key mica belts are the Koderma-Gaya-Hazaribagh belt in Jharkhand, the Nellore belt in Andhra Pradesh, and the Ajmer belt in Rajasthan. Another crucial non-metallic is limestone. Found in sedimentary rocks, it's the basic raw material for the cement industry and essential for smelting iron ore in a blast furnace. The major producing states are Rajasthan, Madhya Pradesh, and Andhra Pradesh. Since minerals are finite, we must conserve them. How? First, by following the 3 R's: reduce, reuse, and recycle. Recycling scrap metals can significantly cut down the need for fresh mining. Second, we must improve our technology to extract and use minerals more efficiently. And third, we should practice sustainable mining to minimize environmental impact. Now, let's switch gears to energy resources. Just like minerals, we classify them into two main types: conventional and non-conventional. Conventional sources like coal and petroleum are finite and polluting. Non-conventional sources like solar and wind are renewable and clean. Let's start with the most abundant fossil fuel in India: coal. Remember the four types in order of quality. Peat has low carbon and high moisture. Lignite is a low-grade brown coal. Bituminous is the most popular coal used for commercial purposes, and anthracite is the highest quality hard coal. The major coal fields are Raniganj, Jharia, and Bokaro. And don't forget Neyveli in Tamil Nadu, which has huge reserves of lignite. Coal is mainly used for thermal power generation and in various industries. Next is petroleum, often called liquid gold. It provides fuel for transport, lubricants for machinery, and raw materials for many industries. India's major petroleum fields are Mumbai High, our largest offshore field, Ankleshwar in Gujarat, and Digboi in Assam, which is India's oldest oil field. Along with petroleum, we often find natural gas. It's a much cleaner fuel and is becoming increasingly important. Major reserves are found in the Krishna Godavari, KG Basin, Mumbai High, and the Gulf of Khambat. It's used for power generation, as a fuel in industries, and as a raw material in the fertilizer industry. These fuels generate electricity. Thermal electricity is produced by burning coal, oil, or gas. These plants are usually located near the fuel sources or near markets to reduce transmission costs. Hydel electricity is generated by fast-flowing water turning turbines in dams. It's a renewable source with low running costs. Major hydel power regions are the Himalayas, Western Ghats, and the Northeast. Now for the future, non-conventional sources. Solar energy is booming, with panels on rooftops and large solar farms in deserts like Rajasthan. India's west coast and hilly regions are perfect for wind energy, with major wind farms in Tamil Nadu, Gujarat, Maharashtra, and Rajasthan. We also have potential in biogas from farm waste, tidal and wave energy along our coasts, and geothermal energy, which taps into the Earth's internal heat with a promising site in the Puga Valley of Ladakh. Finally, there's nuclear energy. It's generated by altering the structure of atoms. The main fuels are uranium, found in Jaduguda in Jharkhand and the Aravalli ranges of Rajasthan, and thorium, found in the monazite sands of the Kerala coast. Remember the key nuclear power plants: Tarapur in Maharashtra, Rawatbata in Rajasthan, Kalpakam in Tamil Nadu, Kaiga in Karnataka, Kakrapar in Gujarat, and Narora in Uttar Pradesh. Just like minerals, we must conserve energy. Energy saved is energy produced. Simple steps can make a huge difference. Use star-rated appliances, switch to LED lighting, and use public transport. Be conscious. Switch off lights and fans when not in use. We must also improve technology for energy efficiency and diversify our energy sources towards more renewables. Before we summarize, let's quickly cover some important box items from your textbook. First, mining hazards and safety. Mining is a dangerous job. Risks include cave-ins, flooding, and fires in coal mines. Miners also face health issues from inhaling poisonous gases and dust. To combat this, strict safety regulations are a must. This includes proper ventilation, gas monitoring systems, and making personal protective equipment, PPE, mandatory. Next, a quick comparison: renewable versus non-renewable energy. Non-renewables like coal and oil are finite and cause heavy pollution. Renewables like solar and wind are inexhaustible and clean. While non-renewables have high running costs due to fuel, renewables have a higher initial setup cost but very low running costs. The choice is clear for a sustainable future. And how do we conserve energy? At home, use star-rated appliances and LED bulbs. In your community, use public transport. And at a national level, industries can adopt energy-efficient motors and recover waste heat. Remember, every unit of energy saved is a unit produced. Finally, a hack for map work. Use mnemonics. For iron belts, think OJ for Odisha Jharkhand. For coalfields, remember JRB for Jaria, Raniganj, Bokaro. Also, pay attention to location cues. Hydel power plants are on rivers, wind farms are on coasts or plateaus, and nuclear plants are often near coasts for cooling water. These small tricks will make map questions a cakewalk. Phew, that was a lot. So, for your final exam recall, remember our master cue. CODE. C is for classification. Know the difference between metallic, non-metallic, and conventional, non-conventional.